This thesis, I was inspired by my own robot pet companions. I wanted to explore public sentiment toward them across different regions. The first research question is the general sentiment toward robot pet companions predominantly positive or negative? The second question asks, does geographical location influence how people feel about digital and robot pet companions? In other words, is sentiment independent of location? To address the first question, I compared the performance of various machine learning models for sentiment analysis using a labeled dataset to identify the most accurate one. The best performing model was then applied to an unlabeled public Twitter dataset containing tweets about digital and robot pet companions from multiple global regions to determine the overall sentiment distribution. To address the second question, I used a chi-square test to examine whether there is a statistical dependence between sentiment and location. Previous studies have shown that positive emotions such as joy and happiness dominate the sentiment landscape. However, those studies did not factor in regional differences. Here's an example of their results showing joy and positivity as the most frequent sentiments. In this thesis, sentiment is defined as a person's emotional reaction, which can be positive, negative, or neutral. However, I focused on 6 specific sentiment categories: joy, sadness, anger, love, fear, and surprise. The sentiment classification was carried out using 3 different approaches. The methodology combines both experimental and quantitative methods. The experimental part involved comparing model performances and selecting the best one for deployment, while the quantitative part focused on data collection, sentiment classification, and hypothesis testing. For the labeled dataset, data preprocessing such as cleaning and vectorization was performed to convert textual data into numerical format that machines can understand. During evaluation, it was found that large language models like Vicuna and GPT-3 yielded lower accuracy scores. In contrast, linear SVC and BERT for sequence classification delivered the highest performance. A key reason for the lower performance of Vicuna and GPT-3 is that they tend to hallucinate and did not follow the instruction to classify into 6 predefined sentiment categories. For example, instead of using anger as a label, they used angry or invented new categories like comfortable or useful. Vicuna even generated 32 different categories instead of the expected 6. Model evaluation wasn't limited to accuracy. Precision and recall were also considered. BERT's classification report and heat map showed excellent metrics, with the lowest metrics still at 83%. Since BERT outperformed the others, I saved both the trained model and its vectorizer to Hugging Face for reuse. For the unlabeled dataset, I collected tweets using Python from 5 continents: America, Europe, Asia, Australia, and Africa. The queries focused on digital and robot pet companions. The analysis showed that joy was the dominant sentiment in all regions. Although linear SVC also confirmed this trend, the data from Africa was too sparse, only 1 tweet, to be evaluated properly. Similarly, the BERT model confirmed joy as the most prevalent sentiment in all regions. Analysis using the Vader lexicon also showed that positive sentiment, represented in blue, was the most common across all continents. For hypothesis testing, I applied a chi-square test. The significance level p-value was set at 5%. To compute the critical value, the degrees of freedom were calculated using the formula rows ditus 1 times columns 1. For a table with 4 rows and 6 columns, the degree of freedom is 15, which gives a critical value close to 25. The chi-square statistic was calculated by comparing observed and expected frequencies. For example, comparing sentiment counts between America and Europe. Using Excel, the computed chi-square statistic was 2.463, which is lower than the critical value of 25. This means we cannot reject the null hypothesis of independence. Therefore, sentiment toward digital and robot pet companions does not significantly vary by location. Other indicators, such as the p-value, further confirmed this conclusion. For example, in another test with a chi-square statistic of 8.6, the results still did not exceed the critical value. Hence, we again failed to reject the null hypothesis, affirming that sentiment and location are independent. In conclusion, for the first research question, the dominant sentiment is positive, especially joy. For the second question, the sentiment is not significantly influenced by geographic location. Summary of findings. BERT for sequence classification was the best performing model. The sentiment analysis of the unlabeled dataset showed a clear dominance of positive sentiment, particularly joy. The chi-square hypothesis test confirmed no significant relationship between sentiment and region. Limitations of this study include: tweets were collected without filtering for age, gender, ethnicity, or culture. Only English-language tweets were analyzed. The sample size from Africa was too small for statistical evaluation. Machine learning models may still produce occasional misclassifications. Recommendations for future research include demographic factors like age, gender, and ethnicity. Expand sentiment analysis to include tweets in multiple languages. Experiment with other models and increase the data sample from underrepresented regions like Africa. Thank you.